ZAS Robotics Motion Kit, Master Robotic Movement, Motors and Control Systems. After robots learn to sense the world, the next fundamental capability is movement. Motion is what transforms electronics into robotics. Wheels turning, arms rotating, robots navigating the real world. The ZAS Robotics Motion Kit is the second product in the ZAS Foundational Robotics series, designed to help students master robotic movement, motors, and control systems using advanced sensors. Controlling motors in robotics is far more complex than simply powering them. Robots must regulate speed, control position, maintain stability, and respond to feedback from sensors. Without proper tools, learning motion control can quickly become frustrating. That's why ZAS Robotics engineered the Motion Creative Board, a UK-designed platform that simplifies robotic motion experimentation. Students can rapidly prototype motion systems while keeping circuits stable, organized, and easy to debug. The ZAS Motion Kit comes complete with the essential components required to build and control real robotic motion systems. The kit includes Arduino Microcontroller Board, Stepper Motor BYJ28 for precise rotational control, Stepper Motor Driver Module, Servo Motor for positional movement, N20 Encoder, Geared Motor for feedback-based motion, TB6612 Motor Driver Module, Accelerometer for motion sensing and orientation detection, GPS Module for position tracking, OLED display for live system feedback, NeoPixel LED strip, 18650 batteries with case and charger, breadboard and jumper cables, programming cable. Everything required to explore the science of robotic motion, from basic movement to navigation systems. The Motion Creative Board provides structured interfaces for motors, sensors, and debugging tools. Students can quickly connect stepper motors for precise rotational movement, Stepper Motor Driver Chip, Encoder, DC motors for feedback-based motion, TB6612 Motor Driver, Servo motors for positional control, sensors like accelerometers and GPS, OLED displays for real-time motion data. This enables rapid experimentation while maintaining stable motor control circuits. Stepper Motor Driver Chip, Potentiometer, Rotary Encoder for user input, Push-button switch, LED, Buzzer, Mini Breadboard, 3-pin and 5-pin free connectors, 3x3-pin configuration. Free connectors and mini breadboard features expand the creativity board to connect any type of sensor in any combination. Imagination is the limit. 3-pin dedicated connector, connector for Bluetooth, power on-off switch, DC power jack, Kit 2 demonstrations, Stepper Motor Precision Control. Learn how stepper motors move with precise incremental control. Students understand how robots achieve accurate positioning for tasks such as robotic arms and automated mechanisms. Servo Motor Position Control. Control precise angular movement using servo motors. Students learn how robotic systems position joints, arms, and actuators with accuracy. Servo motor and accelerometer tilt position control. Control precise angular movement using accelerometer tilt as a remote. Encoder, motor PID control, feedback and odometry. Encoder motors provide feedback about how far a robot has traveled. Using encoder data, students perform closed-loop PID control and odometry calculations. The robot's position based on wheel movement. Sensor fusion navigation. Real robots combine multiple sensors to understand their motion. By combining accelerometer data with GPS positioning, students explore sensor fusion techniques used in modern autonomous systems. Learning outcomes. Students working with the Motion Kit gain hands-on experience with stepper motor control systems, servo motor positioning, encoder-based motor feedback, open-loop and closed-loop control systems, PID control fundamentals, odometry and motion estimation, sensor fusion using accelerometer and GPS, live motor position telemetry via Bluetooth, Motion system debugging using OLED, LEDs, and buzzers. Microcontroller-based motor control architectures. These are the core skills required to build intelligent robotic movement systems. Creative projects and exploration. Students develop motion control expertise through structured learning. 15 foundational motion labs covering key control techniques. 35 creative navigation and robotics projects. Practical experimentation combining motors, sensors, and feedback loops. Example projects may include precision motor control systems, robotic navigation experiments, GPS-based movement tracking, interactive motion control using rotary encoders, sensor-based movement feedback systems. Students move from simple motor control to full robotic navigation systems. Preparing for advanced robotics. The Motion Kit prepares students for advanced robotics topics such as autonomous robot navigation, reinforcement learning for motion control, robotic path planning, autonomous vehicles and drones, industrial robot actuation systems. It builds the motion intelligence layer required for real robotic platforms. The ZAS Robotics Motion Kit bridges the gap between electronics and true robotics. With stepper motors, servo motors, encoder-based feedback systems, and advanced navigation sensors, students gain real, hands-on experience designing motion control systems. Combined with the UK-engineered Motion Creative Board, learners can rapidly prototype robotic movement and develop the skills required for advanced robotics projects. Because once robots can sense the world, the next step is learning how to move through it with precision. Visit our website, explore our GitHub, watch tutorials on YouTube, and take your next step into advanced autonomous robotics, starting today. In this advanced robotics journey, you are not alone. You have the support of the strong ZAS Robotics community. Follow us.